Okay, so here in this video we're going to consider our last volume of revolution. So let's consider something easy. Suppose f of x or y equals x squared. And we're bounded by the first quadrant, where y equals 0 and x equals 0. So our limits of integration would be from x equals 0 to x equals 2. So this is y equals x squared in the first quadrant, say from 0 to 2. There it is. And we're bounded by, of course, the x-axis here. So this is our area. And we would typically draw a rectangle like this. So suppose this time we want to revolve the rectangle about the y-axis. So we notice then that the rectangle, when we revolve it about the y-axis, is not perpendicular, obviously. It's parallel to the axis of rotation. So what would the result be? Just picture taking one rectangle in this region and revolving it about the y-axis. Well, to kind of give this picture a better sketch of what's going on, we reflect it about the y-axis, because that's what's being revolved about. And over here would be -2. And here's another rectangle about where this one is at. And if you envision that, what I would have, one cross-section, by taking one rectangle and revolving it about the y-axis, would be a cylindrical cylinder. So it's kind of like this, as a visual. Here is this book. This is the rectangle right here in that region, one rectangle. And what I'm going to do is revolve it about the y-axis. So the result is, when I round out the book, of course, it's a cylindrical cylinder. So what would be the volume of this piece? Well, if you think about it, the distance around a circle is 2 pi r. So if I undo this, I end up with a rectangular prism, where this length is 2 pi r, because that corresponds to the distance around the circle. What else have I got? Well, of the rectangular prism, this is the height right here. This is 2 pi r, I call this 2 pi r, and this would be the height of the rectangle. And then I also got thickness right here. How thick is that? Well, that would be my difference in the x's. So if I just put it back here, here's the rectangle parallel to the y-axis out here. And when I revolve that one rectangle about the y-axis, I end up with a cylindrical cylinder here. And the distance around that is 2 pi r. And that corresponds to this dimension in my rectangle. The height is the height of the rectangle, and the width is the difference in the x's, right here. So this is the volume by shell then. So volume by shell equals, we'll bring out the definite integral from a to b, we'll bring out the 2 pi, times the radius, times the height, times dx. So the height, we would know, the vertical height, the height of the rectangle, would be the top minus the bottom. In this case, it would be my function. But what's the radius corresponding to? So think right here that this is an x chosen that interval. Right here, this is the radius of that cylinder. So like right here, this cylinder right here that I'm spinning, this is the radius right there. Well, notice that the radius of the cylinder would correspond to the distance from the axis of rotation. So since the axis of rotation is just the y-axis, and if we're over here at 1, then the radius is 1. The distance to the axis of rotation is 1. So suppose at any x in this interval, suppose this is 1.5 right here. So then the radius is 1.5 of that cylinder. but the distance to the axis of rotation is 1.5. At any x from 0 to 2, the distance to the axis of rotation would just be x in this case. But remember, when you're talking about horizontal distance, this is really important. When you talk about horizontal distance, it's always going to be right minus left. Whenever you talk about vertical distance, it is always going to be top minus bottom. So in this case, the volume by shell would be equal to 2 pi times the definite integral from 0 to 2. The distance to the axis of rotation is just x, x minus 0, times the height of the rectangle. Well, the height of one rectangle would be top minus bottom. The top is x squared, minus the bottom, which is just 0, times dx. And you clean this up and make this x cubed, and this would become equal to 2 pi times x to the 4th over 4 from 0 to 2. Put in the 2. 2 to the 4th is 16 divided by 4 is 4 times 2 pi is 8 pi. Of course, obviously, if we put the 0 in, we get 0. Okay, so that is volume by shell. Volume by shell is parallel to the axis of rotation. Disk and washer are perpendicular to the axis of rotation. Okay? And obviously we could see that this means the sum of all of those volumes. This is the volume of one shell, and this represents the sum of all those volumes. Keep picturing more rectangles right here and revolving about the y-axis. Does it represent the sum of all those? Okay, so as some more examples. Suppose we have the equations y equals x squared and y equals 4x minus x squared. Okay, so we have to get the region. So x squared equals 4x minus x squared. Take everything over and get 2x squared minus 4x equals 0. Factor out the 2x, and I get then x minus 2. So x would be 0, or x would be 2. So as a sketch, this is 0, this is 2. When x is 0, y is 0. When x is 2, y is 4. I can put it anywhere, remember. Pick a x in between. When x is 1, y is 1. So 1, 2, 3, 4. And then when x is 1, y is 1. Oh, this is a little misjudged there. I should have that over more when x is 1. So that's halfway. That makes better sense. This is a parabola x squared, concave up. If I pick 1 for this same function, 4 minus 1 is 3. So I get 1, 3. It's negative x squared. It's concave down. So there's my region. So, of course, to find the area would be the definite integral from 0 to 2, top minus bottom, so that would be 4x minus x squared, minus the bottom, which is x squared, dx. And clean it up. That would be the area. So now, suppose we want to find the volume about the y-axis. Well, we realize that when we revolve it about the y-axis, it's parallel to the axis of rotation. So when it's parallel to the axis of rotation, it's volume by shell. So volume by shell would be equal to 2 pi times the definite integral from 0 to 2. Now, if you have any x in this interval, what's the distance to the axis of rotation, which is here? Well, it's going to be that x value minus 0, right minus left. What's the height of the rectangle? The height of the rectangle is top minus bottom. Well, the top is 4x minus x squared minus the bottom, which is x squared, times dx. Yes, we have to clean this up to become negative 2x squared plus 4x, close it, dx. Of course, I would distribute to get negative 2x cubed plus 4x squared. And then now in taking that antiderivative, it would be 2 pi times negative 2x the fourth over 4 plus 4x cubed over 3 from 0 to 2. And obviously put in the 2, then put in the 0, which would just be 0. And there's your volume. Remember that volumes, like areas again, cannot be negative. So again, the volume by shell is 2 pi times the definite integral from a to b. It's of the distance to the axis of rotation. The distance to the axis of rotation times the height of one rectangle. Just draw one rectangle, take its height, times it by dx. Okay, so now we'll work with this same problem. Let's suppose we want to revolve it about the line, the volume, about the line x equals negative 1. So that's right here. So it's still parallel. Parallel is shell. So volume by shell would be equal to 2 pi. The limits of integration obviously have not changed. But what has changed now is the distance to the axis of rotation. So any x in this interval from 0 to 2, how far are you from negative 1? Well, it'd be x minus a negative 1. X minus a negative 1. So think about it. If you're here at 1, how far away are you from negative 1 then? The distance, the axis of rotation, 2 units. If you're here at 1.5, how far are you away from negative 1? Then that would be 2.5. 1.5 minus a negative 1 would become then 2.5. If you're x in this interval, how far are you away from negative 1? X minus a negative 1. The height won't change. The height is still top minus bottom, 4x minus x squared dx. And of course, you have to clean this up to be x plus 1 times negative 2x squared plus 4x dx. And the only way we can handle this is just to FOIL that out. So that would become negative 2. I'm backing this up some. It'd be negative 2x cubed plus 4x squared minus 2x squared plus 4x. And then that would become negative 2x cubed plus 2x squared plus 4x dx from 0 to 2 times 2 pi. And then we take the antiderivative from there. It would be 2 pi times negative 2x the fourth over 4 plus 2x cubed over 3 plus 4x squared over 2 from 0 to 2. Okay? Now let's do it about volume about x equals 2. So what if we're going to take this and revolve it about the line x equals 2? So because the rectangle drawn is parallel to the axis of rotation, it is still shell. So volume by shell would be equal to 2 pi times the definite integral from 0 to 2. Now what's the distance to the axis of rotation? Well, think about it. If you were here at 1, how far away are we from 2? 1 unit away. It's right minus left. 2 minus any x value in this interval. So the distance to the axis of rotation would be 2 minus x. If we were even over here at 3, it would be then 3 minus x. If we were revolving it about negative 2, it would be then x minus a negative 2. It's right minus left. If we were back here at negative 3, it would be x minus a negative 3. If we were over here at 4, it would be then 4 minus x. It's always right minus left to find the horizontal distance. The height of the rectangle would be the top minus the bottom, so it would be 4x minus x squared dx. And again, the same procedure would be make this 4x minus 2x squared, FOIL that out, and then take the antiderivative. Okay, so now what about if we wanted it volume about, let's just do x equals 3. So it'd be volume by shell again, 2 pi from 0 to 2. And it's about x equals 3. So it'd be right minus left, 3 minus x, times the height, which would be 4x minus x squared dx. And let's do some of the old ones. Suppose we want to revolve it volume about the x-axis. Well, now, when we extend this right up against the axis of rotation, remember, this is the solid piece right here. We notice that it is perpendicular to the axis of rotation. So when it's perpendicular to the axis of rotation, that is volume by washer or disk. When there's a clear piece, it's volume by washer. So volume by washer would be pi times the definite integral from 0 to 2. It's the big radius squared minus the clear radius squared. So the big radius squared minus the clear radius squared. So the big radius is the length of the rectangle from here to here. So this would be 4x minus x squared minus 0 squared minus the clear piece, which would be x squared dx from 0 to 2. And how would we clean that up, make that negative x to the fourth? We'd have to square this, square that. That would be 16x squared. Multiply and double these. Square the last. And then this here would become minus x to the fourth. And then they would drop out and take the antiderivative from there. What if we had the volume about the line y equals negative 2? Well, that would be down here again. Draw it right up against the axis of rotation. When it's perpendicular and there's a clear piece, it's volume by washer. So from 0 to 2. The big radius would now be the top minus the bottom. So it's going to be 4x minus x squared minus a negative 2. So the length of the vertical piece is top minus bottom. 4x minus x squared minus a negative 2 squared minus the clear piece, which would be 0. This is the clear piece right here. All of this is the clear piece. So that would now be x squared minus a negative 2. Close it, square it, dx. Okay, so you have to make sure that when it's perpendicular, and as well as when it's parallel, always shade in the rectangle of the enclosed area. And if we had it about the line y equals 4, then that would be up here. Draw it right up against it. And again, it would be volume by washer. But this time, the length of the whole rectangle from here to here would be top minus bottom. So it would be 4 minus x squared squared. The top is 4. The bottom is x squared. So it would be 4 minus x squared squared minus the length of the clear piece, which is right here. That's the length of the clear piece. So that would be 4 minus, this piece corresponds to that function. So it would be 4 minus 4x minus x squared, close it, square it, dx. And how would you clean that up? You'd have to distribute that through and then clean it up, square it, and then square this and combine like terms. But the clear piece here is, again, any vertical distance is top minus bottom. So the length of the clear piece is top minus bottom, 4 minus 4x minus x squared. The length of the big piece is 4 minus x squared. Of course, we have to square it. Okay, so then now how do we approach this in a nutshell? Suppose we have y equals x squared and y equals, say, 2x. So we set them equal. X squared equals 2x. X squared minus 2x equals 0. Factor this out, and I'd get x would be 0 or x would be 2. This would be 0, this would be 2. When x is 0, y is 0. When x is 2, 2, y is 4. This here, pick 1, you'll get 1, 1. So then that is going to be parabola concave up. And if I pick 1 for here, I'll get 2. So this would be 2. And this is a line right there. So the line is above that. So if you think about it again, if you pick 1, you get 1 for this. If you pick 1 for this, you get 2. So therefore that function is on top. Now what you do is, because these equations are solved for y, this is the next important step. So you graph the area bounded by the equations or the curves, and you then decide how you're going to draw your rectangle. You have to decide then how are you going to draw it. Are you going to draw it vertically or horizontally? Those are the two options. Do you draw it vertically or horizontally? I'm going to draw it vertically because these equations are solved for y. If they were solved for x and we had like y squareds or y cubes, then we would draw the rectangle horizontally because it would be easier to do the volumes or the area that way. Since these again are solved for y and these are functions of x, then it will most likely be easiest to do all volumes and areas by drawing the rectangle vertically. You always have a choice of how you want to draw the rectangle initially in that area. In that inscribed area, you can either draw it horizontally or vertically. One way will always be easier than the other. So how do you know? When they're solved for y already, draw it vertically. If they're solved for x and you got y squareds or y cubes or the square roots of y, then you would draw it horizontally. Then you compare it to the axis of rotation. So if I was going to find the volume about the x-axis, well then I notice that it is going to be perpendicular to the x-axis, and since it's a clear piece, it's volume by washer. So volume by washer would be pi times the definite integral from 0 to 2. The big radius squared would be x minus 0 squared minus the clear piece, which is this right here, x squared minus 0 quantity squared. And this would become x squared minus x to the 4th. And you can take it from there and clean that up. You take the antiderivative, now of course this would be x cubed over 3 minus x to the 5th over 5, and you know what to do from there. But just make sure that after you clean it up, you do remember to take the antiderivative. If we were to do the volume about the y-axis, we don't have to redo anything. We now see that the rectangle is parallel to the axis of rotation, so that's volume by shell then, which would be then 2 pi times the definite integral from 0 to 2. Volume by shell is two things. The distance to the axis of rotation. So any x in this interval, how far are you away from 0? Well, it would be right minus left. X minus 0 is just x. Times the height of this rectangle. There is no clear piece in the volume by shell. So the height of that rectangle would be 2x minus x squared, close it, dx. Distribute 2x squared minus x cubed dx, and then take the antiderivative from there. Don't forget the 2 pi. If we were to do the volume about the line x equals 3, well, x equals 3 is out here. How does it compare to the axis of rotation? It's parallel. So parallel is shell. Parallel is shell. 2 L's. So 2 pi from 0 to 2 again. The distance to this axis of rotation is 3 minus x, right minus left, because it's horizontal distance. And now the height of that rectangle is still going to be 2x minus x squared, close it, dx. In shell, don't forget some common errors. There is nothing squared right here. It's two things. Distance to the axis of rotation times the height of the rectangle. If we were to do it about the line y equals 4, well, that's up here. And now, when I compare that to the rectangle in the area, it's perpendicular. So I draw right up against it. When it's perpendicular, it's got to be drawn right up against it. So the volume here by washer would be then pi from 0 to 2. The height of the whole rectangle from here to here. The big radius squared. Top minus bottom. So it'd be 4 minus x squared squared minus the clear piece, which would be 4 minus 2x quantity squared dx. Okay? Volume of the big radius from here to here squared minus the volume of the inner radius. This is we call the inner, this we call as the outer. Or I call this the big radius and the clear radius. Okay? We had no disk here because of the fact we always had a clear piece so far. So remember, volume by disk is, again, if I had y equals root x equals 0, x equals 4, and we're in the first quadrant, so you know what that looks like by now, right there. So if I were to revolve that area from 0 to 4, again, you draw the rectangle. Are you going to draw it vertically or are you going to draw it horizontally? I'm going to draw it vertically because of the fact these are solved for y already. Then I compare it to the axis of rotation. Then I compare it to the axis of rotation. I first don't draw it comparing it to the axis of rotation. I draw the rectangle. If the equations are solved for y, then I keep them vertical. If they're solved for x, or I see y squareds or y cubes, it'd be easier then to usually solve it for x, and then I'll draw my rectangle horizontally and compare it to the axis of rotation. When it's perpendicular, it's either disk or washer. And when it's parallel, it's shell. So if this is my area, and I'm going to revolve that about, say, the y-axis, then it's volume by shell equals 2 pi times the definite integral from 0 to 4. The distance to the axis of rotation, it's about the y-axis, so here x equals 0, so it'd be x minus 0 or just x. And the height of that one rectangle would be root x minus 0 dx. And this is x times x to the 1/2, which would be x to the 3/2. That antiderivative would be x to the 5/2 times 2/5 from 0 to 4 times. And don't forget, when you put the 4 in, it's the square root of 4, which is 2. 2 to the 5th is 32. Times 2 is 64. Double it would be 128 pi over 5. That would be that volume. And again, if this were back here at x equals -2, then it would just be, because it's still parallel, it would be x minus a -2 times root x. And that would become x plus 2. Distribute the root x through, and then take the antiderivative. And if I was going to do it about the x-axis, which is right here, it's perpendicular. There is no clear piece. So volume by disk is pi times the definite integral from 0 to 4 of just the radius squared. There's no clear piece in disk. It's a solid piece, and there's no clear piece. There's no hole about it. So it would just be the radius squared, which would be top minus bottom, squared dx. They drop out, and the antiderivative would be x squared over 2 from 0 to 4 times pi. And there we have it. Okay, so again, the bottom line is get the area, get the equations, set them equal if you have to, graph the area bounded by the equations or the curves, decide how you want to draw it, vertically or horizontally. If they're solved for y, then you want to draw it vertically. If they're solved for x, you want to draw them horizontally. And then you compare it to the axis of rotation. If it's perpendicular, it's volume by shell, or, if it's perpendicular, it's volume by disk or washer. Volume by disk or washer. If there's a clear piece, it's volume by washer. And when it's parallel, it's volume by shell. Volume by shell is two things. Distance to the axis of rotation multiplied by the height of the rectangle. And always keep in mind that vertical distance is always top minus bottom, and horizontal distance is always right minus left.